Hello everyone, we are Team Synopsis from Department of Electronics and Communication Engineering from Tyagaraja College of Engineering, Madurai. So in this video we will be discussing about IC741 op-amp in detail. So in this video we'll be talking about the introduction and the pinout details and function of IC741 op-amp and its specification, internal structure and its working, characteristic graphs and few applications of IC741 op-amp. So IC741 op-amp is just a general purpose operational amplifier. It was first manufactured by Fairchild Semiconductors Company in the year 1963. So the number 741, it has a significance, that is the 741 the IC has 7 functional pins, in which 4 pins are capable of taking input and 1 pin is for the output, thus the name 741. One of the main advantages of IC741 op-amp is that it can provide high voltage gain and can be operated over a wide range of voltages, which makes it the best choice for use in integrators and summing amplifiers.
In this slide, we are going to see about the pinout details of IC741. As you see here, it is the 2 different types of views of the IC741. It has 8 pins, in which pin number 2, pin number 3 and pin number 6 are most significant. Next slide. We can see the functions of these pins in detail. Let's start with pin number 4 and 7, that is power supply. Pin number 4 is V minus and pin number 7 is V plus, that is negative voltage supply and positive voltage supply. Next is pin number 2 and 3. These two are the input terminals. Pin number 2 is inverting input, pin number 3 is non-inverting input. That is, if the voltage at the pin number 2 is greater than the voltage at pin number 3, then the output is low. If the voltage at pin number 3 is greater than voltage at pin number 2, then the output is very high. Next is pin number 4. Pin number 1 and 5. Pin number 1 and 5, it is offset null. This is it is because to nullify this effect, an offset voltage can be applied at pin number 1 and 5, and is usually done using a potentiometer. The next is pin number 6, that is meant to be for the output. If the output is set to be low, it means that the voltage at the output is equal to the negative supply voltage. The rest is pin number 8, which is not connected to any circuit inside 741 IC. It's just a dummy LED used to fill the space in standard 8-pin packages.
Specifications of IC741. The following are the basic specifications of IC741. First one, power supply. Requires a minimum voltage of 5 volt and which can upstand to 18 volt. Second one, input impedance about 2 megaohms, output impedance about 75 ohms. Voltage gain is 2 lakh for low frequencies. Maximum output current is 20 milliampere. Recommended output load is greater than 2 kiloohms. Input offset ranges from 2 millivolt and 6 millivolt. Slew rate is 0.5 volt per microsecond. Slew rate is nothing but the rate at which an op-amp can detect voltage changes. Did you know the high input impedance or very small output impedance makes IC741 an ideal voltage amplifier?
As you see in this slide, this is the picture of an internal schematic diagram. That is, inside the IC741 op-amp, this is the circuit used to do its function. So let's see the working of this internal structure. Before going into that, we must know that this circuit consists of 20 transistors and 11 resistors. All of them are integrated into a monolithic chip. Okay. First, the inverting and the non-inverting inputs are connected to two NPN transistors, that is Q1 and Q2 respectively. Both the transistors behave as NPN emitter followers, with the output is fed to a pair of PNP transistors, that is Q3 and Q4, configured to junction as common base amplifiers. This configuration helps to isolate both the inputs and prevent the possible signal feedback that might occur. Next is the voltage swings at the input op-amp can influence the current flow in the internal circuit, and it might go beyond the active operation range of any transistor in the circuit. The next is the transistor pairs Q8, Q9 and Q12, Q13 are arranged to form two current mirror circuits. The transistor Q8 and Q12 are the controlling transistors, which sets the emitter base voltage of the other transistor in the corresponding pair. The first current mirror formed by Q8 and Q9 are coupled to the input circuit, and the second current mirror formed by Q12 and Q13 are coupled to the output circuit. Now, next is a third current mirror formed by the transistors Q10 and Q11 acts as the high impedance connection between the input circuit and the negative of the power supply V-. It also provides a reference voltage without loading the input circuit and sets the slight base bias current required by the PNP transistors of the input common base amplifier circuit. Transistor Q6 along with resistors 4.5K and 7.5K form a voltage level shifter circuit, which drops the voltage from input amplifier circuit by 1 volt before it is sent to the succeeding circuit. In order to prevent this signal distortions at the output amplifier stage. To balance any irregularities at the input differential circuit, transistors Q5, Q6 and Q7 are used to form an arrangement that takes in two inputs, that is offset null positive and offset null negative, and balances both the inverting and non-inverting inputs accordingly. A small tip here, transistors Q15, Q19 and Q22 are configured to work as class A power amplifier, and the transistors Q14, Q17 and Q20 form the output stage of the 741 op-amp.
Applications of IC741. So as you have seen earlier, IC741 has a very high voltage gain and can be operated over a wide range of voltages. So having this as an advantage, the primary application of IC741 is that it can be used as an amplifier to amplify signals of varying frequency ranging from DC to higher radio frequencies. It can also be used to filter out signals of unwanted frequencies. Secondly, it is used in many computational areas to perform mathematical operations like integration, differentiation and summing. Next, as rectifiers, it can be configured to perform as an ideal diode, that is with no voltage drop at all, and can be used in precise rectifier circuits. And the fourth one is as oscillators. In function, it is used as oscillator in function generators to create different output waveforms like triangular, square and sinusoidal. It is also used in pulse width modulators. As fifth one, it is used to compare voltage signals and determine if they are almost of the same voltage. This can be used in voltage regulators and signal comparators. And last, it is used in analog to digital converters as well as in digital to analog converters. In digital to analog converters, they can take digital binary input from computers or microcontrollers and create a corresponding analog signal.
Moving on to IC741 characteristics gain versus frequency graph. The gain of operational amplifier IC741 is not constant and varies depending on the frequency of the input signal. The graph illustrates the relationship between frequency and open loop gain. You can observe the gain remains constant at around 2 lakh when the operational amplifier is operated at frequency below 10 Hz. As the frequency of the input signal increases, the gain reduces and approaches unity at frequency around 1 lakh Hz.
So this is a brief video about the internal diagram, working and applications and characteristics of IC741 operational amplifier. We would like to thank our Professor Dr. Balamurugan for giving us this opportunity. Hope you found this video informative. Thank you.